Motions of the Earth. There are two motions of the Earth. They are rotation and revolution. Rotation of the Earth. Rotation can be defined as the spinning or the turning of the Earth on its axis from west to east. It takes the Earth about 24 hours, that is a day, to complete one rotation. The Earth is a spherical body with a circumference of about 40,074 kilometers. The surface of the Earth moves about 460 meters per second and about 1,670 kilometers per hour. The axis of the Earth. Now, let's look at the concept of the Earth's axis. The axis is an imaginary feature, or it is an imaginary pole that has run through the center of the Earth from north to south. Now, the axis of the Earth can tilt towards the sun. The tilting of the axis is also known as the obliquity of ecliptic. Now, the rotation of the Earth is in a wobbling manner. Why is it in a wobbling manner? It is so because there are differences in land mass of the Earth's surface. This means that some parts of the Earth are heavier than others. So as the Earth rotates, it wobbles. So the rotation of the Earth is from west to east. As you can see. Now, let's look at the effects of the rotation of the Earth. What does this mean? It means that at the end of every 24 hours, complete turn of the Earth, we experience certain phenomena on the surface of the Earth. These phenomena, which we experience every day, is what is referred to as the effects of the rotation of the Earth. One phenomena is day and night. Day and night is a phenomenon that we experience all the time. During the day, you see the reflection of the sun and you have light. During night, the sun does not appear and you have darkness. Now, let's look at the happening of this phenomenon. Now, let's look at this phenomenon. This is the Earth and this is the sun. The Earth and the sun are both terrestrial bodies. The sun is a stationary body. It means it does not move. But the Earth rotates. Now, as the Earth rotates, the part of the Earth that comes to face the sun experience the rays of the sun. So that part of the Earth is going to have day, and the part that is not facing the sun is going to have darkness. So as you can see, this part of the Earth is having day or light because it is facing the sun, and this part of the Earth is having darkness because it is not facing the sun. Now, let's look at another phenomenon, which is deflection of ocean current. Now, as the Earth rotates, all planetary winds and ocean currents in the northern hemisphere are deflected in a clockwise direction, and planetary winds and ocean currents in the southern hemisphere are deflected in an anti-clockwise direction. This happens due to the differences in the pressure zones of the Earth. The force that causes the deflection in the northern and the southern hemisphere is known as the Coriolis effect. Let's have a look at this diagram. This is a picture of the Earth or the globe. Now, this line is the equator and it is latitude 0 degrees. Now, the equator has divided the globe or the Earth into two equal halves. Now, from the equator to the whole of this region is the northern hemisphere. Then from the equator to the whole of this region is the southern hemisphere. So basically, the equator has divided the globe into two equal halves. That is the northern hemisphere and the southern hemisphere. So as the Earth rotates, all planetary winds and oceans in the northern hemisphere move to the clockwise direction. And all planetary winds and ocean currents in the southern hemisphere deflect to a counterclockwise or an anti-clockwise direction. So let's look at this diagram. This is the equator. And the equator, I said earlier, has divided the globe into two equal halves. That is the northern hemisphere and the southern hemisphere. So as the Earth rotates, all planetary winds and ocean currents in the northern hemisphere deflect in a clockwise direction, and all planetary winds and ocean currents in the southern hemisphere deflect in an anti-clockwise or a counterclockwise direction. Now, another effect of the rotation of the Earth is tide. What is tide? Tide is the daily rise and fall of sea level. This phenomenon happens every day. Tide is caused by three main activities. That is the activity of the moon, the activity of the sun, and the rotation of the Earth. This is a picture of the ocean floor. This picture is indicating that when there is high tide, the sea rises to this level, and when there is low tide, the sea falls to this level. The difference between the high tide and the low tide is called the range of tide. Let's look at this diagram very well. This is the Earth and this is the moon. Now, we said earlier that the moon is having a force of gravity. So as the Earth rotates, the part of the Earth that comes to face the moon, because the moon is having a force of gravity, it pulls its sea waters closer to it. So there will be a bulge of the sea at the region that is facing the moon. Now, an interesting thing happens. There will be another high tide at the opposite side of the part of the Earth where it's facing the moon and having the high tide. Let's watch this diagram. Now, you can see that this part is having a high tide. The blue here is indicating the high tide. Now, at this part of the Earth, you can see that there is no much blue. So it means that this part of the Earth is going to have a low tide. Now, this part of the Earth will also have a high tide. Then this part of the Earth will have a low tide. So in a day, within 24 hours, there are two high tides and two low tides, and they happen at the opposite sides. So someone will ask, why is it that this part is not facing the moon, but it is having a high tide? Yes, as geographers or people who are having interest in geography, we know that the shape of the Earth is not round, but the Earth is spherical. So this is what happens. The moment the seawater at this part of the earth are being pulled to this part, it makes the seawater at the opposite side to pile back or to push back. For example, when you hold the center of a balloon, what happens? It gives you an 8 shape. So this is the same phenomenon that is happening here. Now, the force that creates the high tide at the opposite parts of the earth is called the force of inertia. Now, the force of inertia is acting on the earth because of the shape of the earth or because of the spherical nature of the earth. Tide happens every 6 hours. So, for example, if Ghana comes to this part of the earth, or Ghana comes to this location at 6 o'clock a.m., in 6 hours time, Ghana will be at this place and Ghana is going to have a low tide. In another 6 hours time, which is 6 o'clock p.m., Ghana will be at this part and Ghana is going to have a high tide. Now, in another 6 hours time, Ghana will move to this part and Ghana is going to have a low tide. So within 24 hours in a day, there are 2 high tides and 2 low tides, and they happen every 6 hours. Now, let's watch this diagram carefully. This is the moon and this is the sea. The sea at this point is at low tide. But watch carefully. The part of the earth that will come to face the moon, there will be a bulge in the sea water. So that part is going to have a high tide. So let's watch the video carefully. Now you can see it means that this part of the earth has rotated to come and face the moon. So that place is having a high tide. Now, as the earth rotates, it moves away from the moon and then it falls to have a low tide. Let us have a closer look at this picture. Now, it is the same day, the same place, but you can see that in this picture, there is water under the boat. But in this picture, there is no water under the boat. It is telling us that over here or in this picture, this part is experiencing a high tide. And at the same place or in some few hours time, the level of the sea reduced and then the low tide is what you are having here. Thank you very much.